Assalamualaikum and hi everyone, we are from Group 8. We want to present experiment 6 which is Bourdon tube pressure gauge. I am Fatin Nusharimita Muhammad Fauzi and I want to introduce you to my teammates which are Logarash, Wishwanian and Taba Selvam. First of all, the objective of this experiment is to calibrate the Bourdon tube pressure gauge using the dead weights, and the second one is to study about the Bourdon tube pressure gauge principle. The apparatus of this experiment is firstly the Bourdon tube pressure gauge, and the second one is the dead weight testers, and the third one is 1 kg piston. Next is the theory of this experiment. Firstly, it's about the Bourdon tube pressure gauge. Bourdon tube pressure gauge is to measure the amount of change caused by the pressurized fluid inside coil or semicircular metal tube. This is owing to belief whenever a flattened tube is pressurized, it tends to revert to its circular shape. The tube opens ends is attached on hollow block, allowing the pressurized fluid to enter the tube. When pressure applied, the tube rounders and uncles until the free ends move. The motion is then transmitted to the gauge needle and it will move across the scale to show the reading of the pressure. The second theory for this experiment is the calibration of dead weight tester. The calibration of dead weight tester is the process of comparing the readings of pressure gauge device under the test to the recognized pressure generated by the specific weights.
5.0 Procedure. This is the setup of the experiment. Step 1. The piston weight and cross-section area was measured and recorded. Step 2. The cylinder was filled with oil up until overflow level and the apparatus was tapped gently to remove any air bubbles as a precaution step. Step 3. The pressure gauge reading of unloaded piston was recorded by gently rotating the piston to minimize any friction effect. Step 4. A dead weight of 500 gram was placed on the piston one after another in a convenient increment way, and the reading of the gauge pressure was recorded. To prevent piston from sticky, the piston was rotated gently when adding each of the weight. Step 5. All the load was removed one after another. Step 6. Step 4 and Step 5 was repeated with decreasing order of weight.
Next, I will be presenting about the results of the experiment. In this experiment, the mass of the piston that we use is 1.0 kg, and the cross-sectional area of the piston is 3.1731 times 10 to the power of -4 meter squared. In this experiment, we repeat the procedure for 3 times and take the mean value to ensure a more accurate results. Next, sample calculation of the results. First, to calculate the theoretical pressure, we must first take the piston weight divided by cross-sectional area of the piston. We will repeat the calculation for each of the mass loaded. Next, to calculate the percentage error, we must take the absolute value of P theoretical minus P experimental divided by P theoretical multiplied by 100% to calculate the percentage error. Moving on to discussion, first, as seen from graph 1, both of the Bourdon gas pressure and true pressure will increase as the weight increases. The difference between the Bourdon gas pressure and true pressure is probably due to the source of error during this experiment. For the graph 2, it is observed that for both increasing and decreasing pressure, the percentage error is decreasing. This is due to the increasing true pressure over the time. Next, source of errors and ways to overcome. First, air bubbles were trapped in the tube which connecting the Bourdon pressure gauge to the piston. To overcome this, we must first get rid of the air bubbles before proceeding with the experiment. Next, parallax error. To avoid this error, we must ensure the observer's eye to be perpendicular to the scale of reading when taking the reading from the Bourdon gauge pressure. Next, friction in the piston. To avoid this, we must first turn the piston whenever the weight is loaded or unloaded. Fourth, the unstable condition of piston. To overcome this error, we must only take the reading after ensuring the piston was stable. And lastly, uncalibrated Bourdon pressure gauge. To avoid this, we must first calibrate the instrument before starting the experiment. repeatability and accuracy of equipment. Repeatability refers to the ability of the equipment to gain the same result under the same condition, whereas accuracy refers to the degree of difference of the results to the theoretical results. Hence, from this experiment, we can conclude that the equipment that we use, the Bourdon pressure gauge, has great repeatability and accuracy.
Finally, I'm going to talk about conclusion. In conclusion, when heavyweights are utilized, the calibrated pressure of the Bourdon gauge approaches real reading. Only when heavyweights are used is the hypothesis valid. As per calculations, we are able to see that the percentage error for the lighter loads are greater compared to the heavy loads. Moreover, based on the graph, the calibrated pressure is directly proportional with true pressure.
This is a list of reference that we used to do this experiment. Thank you.